Right. So right now we are at lecture number 9, the very last official lecture for 194A, because next week we'll have a panel discussion, and I'll talk more about what that is in a little bit. But we didn't have a lecture last week, and last week the topic was supposed to be about remote databases, in particular Firebase, and I wanted to actually spend the first maybe 15 minutes of today's class or 20 minutes just talking about some of lecture 8 content, just because I would feel remiss if we didn't at least touch on that before the class ends. So I already posted the lecture slides for both this lecture and last week's lecture onto the class website in case you want to follow along. So let me first backtrack, and then we'll talk about remote cloud databases first. And then I want to spend the majority of today's class talking about all the things that we're not covering in the class, just because this is a 1-unit class and there's so much in the world of Android that we don't have time for. But in terms of the content from last week, remote cloud databases, this is so important, I think, going forward for app development, because every app is going to need to get data from somewhere, right? And you have a couple options, right? One is you could use a local database, which means that you have data which already exists in the memory of your phone. So they're saved on disk somewhere. And that's like SQLite. You're having disk on data and you query it and you display it. What we just did in the Yelp clone assignment was we queried a web API. And Yelp is basically maintaining the data somewhere, and we're showing it in our application. Or a third option is you can have your own backend service. So if you have your own startup, you probably have some custom logic or some business. You probably have some business logic or some proprietary data that you have in your backend. And so, of course, you'll need to be able to surface that in the application. And for that, you need a custom backend service. So the remote cloud database is pretty magical because it combines the benefit of having local storage with SQLite, so you can query things in a cache from your phone, and the flexibility of querying things through a web API, but you can also have your own custom logic. So it's kind of the best of all of these. That's kind of how I think about cloud databases. And when you think about having your own backend, the standard approach up until a couple of years ago was that you would have a technology such as Django, which is written in Python, Ruby on Rails, Node, which is JavaScript, and you would rent out a server from Amazon or from DigitalOcean or somewhere, and you would deploy your backend. But this actually is pretty painful. You would have to think about, I'm going to use some database like PostgreSQL or MySQL and create that with the proper version on the server that I rent out, along with setting up the proper version of Django or Ruby on Rails, etc. I'd have to worry about redundancy and robustness. So what if my database goes down? I don't want my whole startup to die just because one server failed. You have to think about scaling. So if I suddenly have a huge growth of users, how do I handle that? And also things like security, right? Database passwords, key rotation, all these things that you typically would want someone with expertise, and you want to have a full-time person thinking about that rather than you, who is working on the product development, the marketing, everything else that comes in with the startup. And just zooming out a little bit, I think the point here is that Firebase makes this process much simpler. And you can kind of think of this similar to the transition that has happened in the past 20 years, where in the 1990s, if you were trying to do a startup, your first headache would have to be, let me go buy a computer and have software running on this physical computer where I can, be able to respond to queries on the internet. So with the invention of things like Amazon Web Services, AWS, or DigitalOcean, or Linode, now you don't need to have a physical computer. So the cost of being able to quickly get a server which can run your web application or backend application is so much lower. And now what Firebase is doing is going one step further. So now, instead of having to even create a server that is deployed somewhere, all that complexity is going away too. Now, literally all you need to do is write the client code, and all the backend code is taken care of for you. And that's what Firebase, that's kind of the the magic of Firebase. And it's called a backend as a service. So it's a platform for hosting your database, doing management, deployment, etc. And it's free for most students or toy projects. The idea is that there's a pretty generous free usage tier, and only if you go beyond that, so if your app blows up, only then do you pay for data that you're using. And that's a pretty good trade-off, because that's like a good problem to have. If your app does blow up, then you would probably be happy to pay $10 or $20 a month just to keep it running. But in the meantime, it's free to experiment with and learn with while you only have a couple hundred users. So some of the main features of Firebase are that it's super easy to set up and integrate with mobile apps. You have a web UI to modify and view data. And there are APIs to perform CRUD operations. So things like the common things that you do in any database: create data, read data, update it, or delete data. All of that can be done through APIs from Firebase, so you don't have to invent your own. One of the things that you should realize about Firebase is that it's a NoSQL database, which means that it's not structured in the same way that MySQL or PostgreSQL is, right? So SQL is structured query language. So NoSQL is kind of a weird name, right? You're kind of identifying something by what it's not. So it's kind of a very weird way to name something. But the reason why it was called NoSQL, I think the name came from probably the early 2000s and the mid 2000s, is because prior to that, almost every company in the world was using a SQL database. And because they were so prominent, the best way to identify these new kinds of databases like MongoDB, the best way to identify that new class of databases was by saying what they're not, which is NoSQL. So the benefits of having NoSQL are that it's very simple to modify and update the data. And you also have horizontal scalability. Horizontal basically means that you can just add in more servers and you get more scalability. Kevin just wrote, "Are you presenting slides?" Oh my gosh, have I not been presenting this whole time? This is like the second time this has happened. Okay, can you all see my screen now?
Yep.
Yes.
Oh, this is sad. This is the end of the quarter for you. I just talked for 10 minutes without any slides. Okay, let me quickly show you. So this is all I covered so far is basically what I said. Backend as a service is something like Firebase or Heroku, which manages all that deployment of servers for you. And now NoSQL, right? So you have, thanks Kevin for pointing this out. Now we have NoSQL. The benefit is that it's much simpler to kind of update the schema of the data. But the downside of a NoSQL database is that some queries are more expensive. So there's a really fundamental part of SQL queries, which is called joins. So you can take one table of data and join it with another table, and you can kind of do more complex or sophisticated queries, which are quite a bit harder to do in NoSQL. You have to be a lot more thoughtful about how do you structure the data so you can always retrieve it in the way you want. So there's a term called ACID, which basically talks about transactions in database and what guarantees you have about when you update or query data in a SQL database. What kind of guarantees do you have? A lot of that is harder to come by with NoSQL databases. So Firebase is the platform which is owned by Google, which basically does all this for you. And the thing about Firebase is that it's intended to be the one-stop shop for everything related to building out your app. And so there's a ton of different services. I'm definitely not going to go through all of them in the next 5 minutes, but I want to just point out a couple which are the most common: Cloud Firestore, authentication, cloud storage, and analytics. That's all I want to just touch on very briefly. And the rest of them you can read up more later on. But Firestore is probably the most important. This is the database, and they describe it as a flexible, scalable database for mobile, web, and server development. And the really cool thing about Firestore is that it keeps data in sync across all clients through real-time updates. And I'll show you an example of that. And the other thing that you get for free with Firestore is automatic offline support. So you know how I earlier mentioned no SQLite. So you have a database on your phone where you can query data and show it in your application. So Firestore gives you some of that flexibility, some of that ability to have offline storage for free. And so that's one other really powerful thing about Firestore. And the reason I talked about NoSQL just now is because Firestore is an example of a NoSQL database. And the two terms you should think about when you are dealing with Firestore are documents and collections. So all the data in your application is going to be stored in a document, which is, you can kind of think of it like a JSON object. And these documents must live inside of a collection. So you have your Firestore root, which is like the root of the database. And then inside of that, you have different collections. So the collections are what will hold on to all of your documents. So in this example, we have two collections called posts and users. And inside of those collections, we have different documents. And now the interaction with your application and Firestore is identical to what we just did with Yelp. You're going to make a query to Cloud Firestore using the APIs that are provided for you by Firebase. And then they'll give you back a list of content matching that query. Okay, that's what I wanted to talk about for Firestore. And let me just do a quick example. So here, let me show the code. So I made a very simple toy app, which I published. I made a video about it too, so if you're interested, you can go through the tutorial video. But what this app is doing is you can update your status using emoji, and you can only use emoji. So the idea is that I can go here, and then if I try typing in some text, it says only emojis are allowed. But then if I go into the emoji thing, I can put out some characters like that. And now you can see how it got updated right here. So it's actually pretty interesting. I made this app. I didn't really think anyone would use it, but I have all these people who have downloaded the app, and they're also updating their own emoji status. But the thing I wanted to show you is the backend. So here is the Firebase project, which is powering this application. So I just updated, here's the Firestore database. I have one collection called users, and here are all the users in the app. There's like 400 or 500, and this is my user. And you can see how I just updated my emoji to be that gift icon, right? And this, this symbol. And so you can see that being reflected here. And the really cool thing, let me show you, if I update it one more time. Halloween just passed, so we can put these pumpkins, right? So you can see right here immediately in the Firestore UI, it got updated immediately. And so what that means is everyone else who is in the app right now will get that update immediately. So the other really amazing thing is that let's say someone else updates their status, so then their emojis would change. So let's say I update this. And I insert some emoji like the confetti thing, right? And so immediately it got updated in my app. And the cool thing about this is that there was no additional code for me to write. All of this is done for you as long as you're using the Firestore API properly. So that's what you can see we're having here. So basically, I'm not going to walk through the code in too much detail, but the implementation of this application is a recycler view. So like normal, we have an adapter on the recycler view and a layout manager. So the adapter is what's doing the actual data fetching. And you can use something called a Firestore recycler options, which is basically saying I have a recycler view here, and the data for this recycler view is powered by a query from Firestore. And here is that query. So I'm saying set query, and I pass in this query object. And here is where you can say val query is equal to db.collection. So I want to query on the user's collection. I want to order all of the things I get back from the user's collection by the updated time. And updated time is referring to this field on the user object. And then I want to query that in the descending. So the most recent thing should be at the top of the list, and the oldest update should be at the bottom. And I only want 200. I want to fetch 200 items. So if there's like 10,000 people, I'm not going to fetch 10,000 objects from the database. I only want 200. And so that's all it is. So with that, you get automatic polling for free, which is how we're able to power this automatic updates that I showed you. So any questions about this? Kevin is saying, is the emoji only restriction front end only? Yeah, so in this example, in this app that I built out, the emoji restriction is only on the client right now. So like I could technically, if I really wanted to be a troll, I could update my status here because I'm like an admin, right? I could update this to be ABCD and that would work and be reflected in the app properly. But there is some other functionality in Firebase called Cloud Functions. So let me show you what that looks like. So in Cloud Functions, what you can do is you can periodically go through your whole database and validate different things. So for example, if I wanted to make sure that there are no users in Firestore who have a non-emoji status, I could be doing that also with Firebase. And in some ways, that's better because you don't want to trust the client code, right? The client could be manipulated or it could be adjusted to show a non-emoji status. But right now, that logic all lives on the client right here. Yeah, that's a really good question. I don't have the best answer for you. There is on AWS. So AWS is pretty much like, at least back in the day, it used to be pretty self-service. Like they had a bunch of different things and it was up to you as a developer to manage all of them and how to fit them together. A couple of years ago, they came out with something called Elastic Beanstalk. My interpretation of Elastic Beanstalk is that it's kind of trying to build out an equivalent thing to Heroku, which is like a back end as a service, right? So I think that's probably the closest you can get to like punting the headache of the back end in the Amazon world. I think like the ultimate goal is you're an Android developer. You want to worry about writing Android code. You don't want to worry about managing a database or a backend. And so I think in the Amazon world, Elastic Beanstalk is the best you can do. But I really don't think there's anything close to Firebase. And in some ways, you don't really have a choice other than to integrate with Firebase. For example, if your app is going to have notifications, and pretty much every meaningful app is going to have notifications in some form, you need to use Firebase Cloud Messaging, FCM, in an Android app. And so in some ways, there's no way to escape Firebase. There's no way Amazon could provide that because Google owns Android. And so I think if you want to be a serious Android developer, you have to get familiar with Firebase. And I think the other thing that's nice about Firebase is that like Google knows that it's not like a one size fits all solution. So out of those things that I showed you here, like there's literally, I think this is 1 year old maybe. There's probably more services that were added into the Firebase ecosystem. You can pick and choose what you want. So for example, a lot of like when I worked at Pinterest, we used analytics in order to track some very key analytics in the Pinterest app, but we didn't really use anything else. And we also used cloud functions or cloud notifications to send notifications out to devices, but we didn't really use anything else like Firebase A/B testing or predictions. All that stuff we had in-house at Pinterest, but there were a couple key services that we used. So I think that definitely if you're building out a new app, certainly you want to look at the tools provided by Firebase and see what you can leverage. And where it doesn't make sense or where you have something that's very custom to your app, for that particular thing, you can either go back to Amazon or do it your own way using your own server.
Great. That's very helpful. Thank you.
Mm-hmm. Right. So that was basically catching up with what we didn't talk about last week. Now I would like to come back into lecture 9, which is today. And basically, the objective today is like a laundry list of everything we haven't talked about yet, which is there's a lot. And again, I'm not going to really go in detail just because this is not supposed to be like a deep dive into all the things we haven't covered. It's basically telling you what we haven't covered so you can learn more about it if you want. In terms of where we are, you all know this diagram now really well. We are at week 9. So congratulations on finishing all the work for the whole class. There's nothing else expected of you. The key thing that I want you to think about though, or remember, is that next week we have the industry panel discussion, and we're going to have 4 people. I'll in the recap email, I'll send you their names. There's like Christina, Anise, Chuki, and Sam. And I'll tell you more about where they are, but they're all really well-accomplished Android engineers who have worked at Pinterest, Robinhood, Google, Meetup, doing Android development. And so I think it's a really good opportunity for each of you to be able to ask questions to these people who have been doing Android for a while, and they also haven't been doing Android. They haven't been doing Android their whole career, many of them. So it'll also be a good opportunity for each of you to learn about why do they enter into the world of Android as opposed to iOS or web development or some other field of engineering. Oh, cool. So then now it's just going to basically be a walkthrough of the different things that we haven't covered. And I actually would like this to be a discussion. So especially near the end, I'm going to be talking about things which are not even Android related, like game development and cross-platform technologies. So if anyone here has actually worked with any of the things I'm talking about, I would love for you to just interrupt me anytime and we can talk about it. So in terms of what we haven't covered strictly within Android, there's a really important topic called fragments. And I want to talk about that for 2 or 3 slides. So a fragment is a reusable portion of UI that lives within an activity. In all the projects that we've done so far, we have only worked with activities. We haven't even talked about fragments or used fragments in any way. But they're really important for Android as you get to bigger apps that need to be working on different screen sizes. So the key idea here is that you can have multiple fragments contained in one activity. And that's important because it can help you on different sizes of devices. And you can also reuse common UI across your app. So if you have, for example, like a profile fragment and you use that in multiple places, fragments allow you to put that into multiple different activities. And you know how we talked about the activity lifecycle 2 weeks ago, and how it goes through the setup phase and then the destroying phase? Fragments have a similar lifecycle, but it's actually a bit more complicated. And the reason why fragments were invented is because the Android team at Google, Android as an ecosystem came out with a tablet in 2011. So before 2011, there were no Android tablets. And with the introduction of tablets, they needed to figure out a way to have multiple pieces of the UI show up in one activity. And so, for example, on a tablet, you could have one fragment over here, which is the kind of list view, and then one more, which is the detail view. And that same UI on a phone would have one fragment on each screen. And that's the flexibility that you can take advantage of with fragments that you couldn't do with activities. So if you think about the differences between a fragment and an activity, there are a bunch of methods defined on the activity that are not available on the fragment. And so when you're in the fragment, it has to live inside of an activity. And so what you can do is there's a property on the fragment called getActivity, and that will look at the parent activity, and then you can access all of those methods on the activity. So if you decide to refactor any of your projects to use a fragment, just keep that in mind, that most things should just simply work if you rename it to be a fragment, but you need to potentially change how you're getting some of the properties based on the enclosing activity. We also have this intent system on Android, right? And the way you're able to pass or get information within a fragment is, again, using intents, but that intent lives within the enclosing activity. So the fragment itself will not be launching the intent, that'll be the activity. And then the actual names of the lifecycle methods are a bit different between the activity and fragment. So for example, in the activity, we have an onCreate method. The analogous lifecycle method for a fragment is called onActivityCreated, which basically means that my parent activity has been created. And so now the fragment can call this method onActivityCreated, and you can do whatever setup you need at that point. So I mentioned how the fragment lifecycle is more complicated. Here's the activity lifecycle. And I think most Android developers have a decent understanding of the activity lifecycle. And especially if you go out to do an interview, you will probably be asked about the activity lifecycle. The fragment lifecycle is quite a bit more complicated. And I think most developers don't actually know too much about this. But it's just worth looking at this diagram for a few minutes so you can get familiar with some of the vocabulary. But I don't think you'll typically be expected to like remember what lifecycle method comes after the previous one. So in terms of using fragments, there are two ways. You can either have a static fragment, and static means that you're actually defining a fragment component in the activity. So if you go into the underlying layout, you can actually drag and drop out a fragment. The same way you can drag out like a text view or a button, you can also drag out a fragment. And that's a static fragment because you're defining it in XML. Or the more common way of using fragments is a dynamic fragment. And what that means is you add a container to the layout, for example, a frame layout or a constraint layout, and then you programmatically in Kotlin code, you will create and add the fragment into that container. And that is probably what you should be doing, or that's what most people will do, because the point of fragments in some sense is to be dynamic, right? Based on the screen size or the navigation that you want to do, you will create and add in different fragments. So we don't have time to, we don't have time to kind of go through a code example, but I'll leave a link. This is a GitHub repository where I go through an example of a very simple fragment. And then you can kind of toggle between the idea of this demo is that depending on which button you tap on, this bottom portion of the screen is a fragment which will be swapped out depending on which button you press. And so both of these exist in one activity, but you can have two fragments in the same activity. So it's like a very simple demo of how you might be able to use fragments in your own application. Yeah, and then Dean is pointing out, I use fragments for the overview and review tab. So that's a really good example, right? So if I actually go back to, where is it? Here's Dean's thing. Yeah, so here, we have these tabs, right, for the overview and review. This is a really good example of how we have one activity or in one screen of the phone, we want to be able to show two very different kinds of content. And so that's where we can use the fragment model here as well. All right, so that's it about fragments. Any other comments or questions about fragments? Oh, okay, so one other very large area in the world of Android that we haven't talked about at all is called services. So services are background tasks used by an app. So everything we've done so far is activity-based, which is actually showing a UI to the user. So it's something that there's a screen that comes up and the user can interact with the different buttons or components on the screen. But there's also a lot of things that you can do in an Android app without a UI. And that's where services come in. So for example, if you want to handle a very expensive network operation or play music or perform file I/O, none of that requires a full screen UI, but you do want some process to be running, which will do all that work, right? So for example, if you're downloading or uploading like 20 very large images, like you're backing up a day's worth of photos, right? So you have like 50 photos on your phone and you want to upload all of that to some service, then you don't want the user to have to open up a screen and then wait for 10 minutes while all that is happening. You would much rather use a service where in the background, all that can be happening and the user can. And then in the same way that activities have a life cycle, in the same way fragments have a life cycle, services will also have a life cycle. And so there's an onCreate, onStart command, and onDestroy. And kind of as the name implies, you can create a service, and then the service can actually have something which will trigger it to start. That's onStart command. And then the service can also be destroyed. So depending on what kind of work you're doing in the service, you have to think about where are you allocating and cleaning up resources. You can also broadcast a result when a task is complete. So this is exactly what the work Jason did in his application, right? So there are some system services, and those things can actually broadcast something using a broadcast that your application can then listen for. And so if you want to be notified of something changing on your device, then you can register a broadcast receiver. And so, for example, if I want to be notified when does my connection get lost or get updated again, like come back, then I can use a broadcast receiver for that. That's literally all I had for services. You could probably have like 1 or 2 lectures dedicated to services. And if we had like, a 3-unit or a 3-credit class, we probably could do that. But this is something that I just want you to be aware of, and then you can learn more about it on your own. All right, the next topic is around testing. And this is a huge, huge area, not only of like debate of how important the different types of testing are, but also the best practices around testing. So there's still an area where I don't think there's that much agreement between many developers. At a high level, the way I think about testing is through this testing triangle. So just curious, who here has heard of the testing triangle before? Has anyone heard of it? So this is the testing triangle. Basically, the idea is that the base of the triangle are the types of tests that are the most common and easy to write. And the higher up that you go on the triangle, the more time consuming it is to write the test, but also the higher fidelity the test is. And so what I mean by that is if you have an end-to-end test, so an end-to-end test would, for example, be I open up the Yelp app and I look at the main screen and I validate that I have 10 different restaurants showing up or whatever the number might be. That's an end-to-end test because you're actually using the Android app to validate something. You're using it as an actual user, right? But the issue with that is it's very flaky. For example, what if you don't have internet at home? So that test will fail, but there's no issue with the underlying source code. The issue is with your home network. Or what if the Yelp API is down? Then again, there's so many things that could go wrong, which the test could fail, but it's not actually the fault of the Android code, right? And so whenever you have a situation where you're writing code and the test fails, but it's not due to your code, then you start losing trust in the test, right? The test becomes very noisy and flaky because it's not actually giving you the signal that you want. So that's why end-to-end testing is kind of tough and you don't really want to trust it too much. The next layer below that is called integration testing. And that's not an end-to-end test in the sense that we're only looking at the interaction between two components. So for example, you have something called like a repository, which is where the data comes from. And then you have your kind of view layer. And so you might be testing, okay, assuming that I have this data in my repository, can I test that the view acts appropriately? All right, so that's a less flaky test because you're not relying on the network anymore, but it still is interacting between two different components, and you will need to run that test on an emulator, and so it'll be more expensive. And the cheapest kind of test is a unit test, which is this has nothing to do with Android. For example, I might be writing a function which sorts a list of data by the time they were created, right? So that has nothing to do with Android. I could write a unit test saying, okay, here are 10 objects. I want to sort all of them by the creation time, and then I'll test that the objects are truly sorted using my algorithm and manually. And so that's a good example of it's 100% reliable, right? If it fails, then you know something has gone wrong with your code, and it's quick to run and has nothing to do with Android. And so hopefully that kind of gives you a sense of why is Android testing hard? Because the higher fidelity your test is, then the more it'll be what the user is testing, the user is doing, but it's also a lot more flaky. So for example, if you have a dropdown in your app, then that dropdown will take time to actually show the contents of that dropdown. And so that's like one more way that your test could fail, even though it's not your fault. A common framework that you might hear for end-to-end testing is called Espresso. So Espresso requires an Android emulator, and it'll actually simulate a button press, for example. So it'll say, okay, tap on this button with this ID, wait for 3 seconds, and then check the results of the UI. That's how an Espresso test might work. Another kind of testing is integration testing, where you check the interaction between different components. And a common library for this is called RoboElectric. And then the third kind of testing is called unit testing. And again, there's no interaction with Android here. You can just use something like JUnit or Mockito to run the tests in your own environment. All right. The next the next thing that we haven't talked about, which again could be probably 2 or 3 lectures alone, would be app architecture. So what is architecture? Architecture is the fundamental structure of a software system. And so when you think about architecture, it's inherently, architecture means that it's something hard to change. Like, so once you pick an architecture for your application, then that will dictate how many other things are implemented. So that's why there's a lot of debates in the world of Android about what is the best app architecture, because inherently architecture means that you're kind of laying the groundwork for everything else that comes after it. It's basically the way of how do you organize your code. So depending on the architecture, that will have consequences around how easy is it to debug your code. If you have a new developer on your team, how easy is it for that new developer to get onboarded and to be productive? So for example, if you have one file which has all the logic for the whole application, then very quickly when you get to 2 or 3. So architecture is a way of how can you cleanly divide up the code in your application so that people don't step on each other's toes as they're making changes. And the way to think about architecture is, what are the different responsibilities of any mobile app? And there's a couple different components here. One is the UI or view layer. Every application will have some sort of recycler view or text view or something which is showing data to the user, right? That's the first part. The second layer is the data classes or the models. For example, in the Yelp assignment, we have at least those 2 data classes which define the data that we're getting back from the Yelp API. So the models are their own component of the app. Then you have something called the repository, and the repository is responsible for holding or retrieving all the data. So in our case, in the Yelp example, we used something called retrofit in order to retrieve all the data from Yelp. All of that logic could be its own component in your application. And then finally, you could have some business logic, which is handling all the changes that could happen in the app. So for example, once I get back the Yelp data, you could imagine a bunch of filters where the user is saying, I want to only look at restaurants which are open now, or I want to sort them in a certain way. So that would then be business logic, which your app is implementing, and then you could have that be its own component. So, I mean, the main takeaway from the app architecture is a pretty big topic, and there's not actually a right answer. The right answer will depend on how much logic do you have in these different components, the UI layer, the data layer, the repository, and the business logic. So if you think about the common kinds of architectures that are out there, the objective for all of them is the same. The way they go about doing that is different, but the objective for all of them is try to avoid having all your logic in one big activity. And that's kind of what, if you look at the 3 projects that we've done, because the projects are relatively simple, most of the logic lives inside the activity. Right? I mean, so you have the adapter, which does a lot of the work as well. But for the most part, all the logic that we wrote is in the activity. And so typically, as you start to add more and more features into your application, you want to avoid that pattern. You want to be able to more cleanly separate the different parts of your app. There are 3 app architectures that I just want you to know. I want you to have heard the name of them. We're not going to talk in too much detail about like what are the differences between them, but I just want you to have heard the name so that later on, if someone mentions it to you, you're like, oh yeah, I've heard of that. Let me Google for it. So one of them is called MVC, Model View Controller. One is called MVP, Model View Presenter. And then the other, which is I think the most popular, is called MVVM, which is Model View View Model. And the idea here is that the model is basically the data. The view is what is the user seeing in your application. And the third acronym, the C or the P or the VM, is referring to how should you be able to retrieve the data and massage it so that it's used in your application. So these are 3 different ways of organizing the code. There are 3 different opinions about how to organize the code in your application. And when I was teaching the class in spring, in the panel discussion, there was one person, Shasha, who had a really insightful comment, I thought, which is that whenever you're doing something in the world of software, or actually pretty even beyond software. When you have really smart people who disagree on something, that's typically an indication that there is no correct answer. Does that make sense to people? So like, if you look at the world of Android and there's a lot of smart people will debate for hours and hours about, oh, should I use MVVM for my application or should I use MVP for my application? And the fact that you can have this debate means that it's probably not the case that one of them is obviously better than the other. It's really going to depend on what kind of application you're building. So if you're starting out, then I don't even think it matters that much. Just choose whatever is easiest based on your understanding, and then you can change it later. So the main thing I wanted to talk about here is that the development of games, mobile games, is actually a very, very different kind of app development compared to what we've been doing. So the kind of thing that we've been learning about in this class is data-rich apps where the user can interact with like buttons or different APIs and show data in the application. That is very different from the kind of thing that we're seeing here. So you have Candy Crush Saga or Angry Birds or World of Candy. These are things where you typically are moving around some world. You collect like tokens and you have lives and you have physics and all that stuff. That's a very different kind of thing that you typically wouldn't really use the Android View components for that kind of development. And so what Kevin mentioned is you almost always will be using a game engine for this rather than the kind of Android development that we've been doing. And why do you want to use a game engine? Well, there's a couple key reasons. The first one, which Kevin mentioned, is that you have cross-platform capability. So if you end up using Unity, you can actually very easily take your Unity project and turn it into an APK and an IPA. So you can have both an Android app and an iPhone app based on that one Unity project, which is a huge benefit compared to having to write the code both on Android and iOS. The other thing is that when you do things like Angry Birds or Candy Crush Saga, a lot of the complexity will come from the physics, the lighting, and the 2D and 3D graphics. So all of that complexity is handled for you, or at least you have it more manageable in Unity or Unreal Engine compared to in the world of Android where you guys have like these buttons on the screen or text views. None of that is really relevant to the kind of app development that we've been doing. And the other thing that I'll mention is that when you develop a game, I would say that games typically don't have as many platform-specific differences, right? So when I play Angry Birds on Android or if I play on iOS, the experience is relatively similar, right? Whereas if I use, I don't know, the Instagram app on Android and iOS, depending on the norm of that platform, like depending on where should the action bar be or what is the style of buttons, that might actually affect the implementation of my Instagram app on Android versus iOS. So because of that difference also, for games, you can use something like Unity or Unreal Engine, whereas you probably don't want to do that for any of the things that we've been building out. The two most common game engines are Unity, and there's one more called Unreal Engine. I think Unity, I haven't done too much game development. Kevin might be able to speak to it more, but I think Unity is more popular. And there's actually a lot of developers who make their career out of being a game developer within Unity. So this is definitely a very interesting option if that's the kind of thing that you're interested in. So yeah, this is like a very different kind of app development than what we've been doing, but also an area of active development and a lot of interesting work to happen here. All right, and so to wrap up, we have like 10 minutes left. The last topic I want to talk about today is alternatives to native app. So all of you have just spent the past, 8 weeks learning about Android. And so now I want to tell you that potentially going forward, there are ways you can build an Android app without having to learn Android development. And what I mean is that there are a lot of cross-platform technologies that are trying to do what Unity is doing, right? So the magical thing about Unity is that you can build it once with this C# language, and then you can create an Android app, an iOS app, a desktop game, or even a Nintendo Switch game. The same thing is trying to happen to a lesser degree with Android and iOS apps. So right now, when you are a company like Pinterest or your Twitter, you have to have two different teams. You have to have one team of Android developers and you have another team of iOS developers. And typically people only care about Android and iOS because the vast majority of people will be using your product through mobile, right? If you're Twitter or Pinterest or a consumer application, you don't really care that much about web. You care primarily because 90% of your users are going to be interacting through a mobile app. And so the idea here is that, I mean, that's too strong a statement. You care about web, but Android and iOS are the two platforms where the form factor is similar enough, but you have to do very different work to enable that. And so the problem that we're trying to solve with things like React Native are that I don't want to do double the work to ship two app platforms. And the other thing is that the developer experience is really quite bad for Apple iPhone development and to some degree Android development. Although Android development is not that bad, but with when you create a new mobile app, you have to then get it approved by Apple and get it approved by Google. And sometimes there are arbitrary reasons why Apple will reject your app. And there are actually a lot of horror stories of how, people have been publishing an app on the App Store for a year. And then all of a sudden, Apple decides, you know what, we don't actually like you anymore, or we think that there's something bad with your app and we're not going to allow it, or it'll just take a lot longer. It'll take 2 or 3 weeks for you to get approved. And that can really slow you down. And so there are two major platforms that are trying to solve this problem. And basically the idea is that we're going to write code once and have that turn into both an Android app and iOS app. So the first one, which is quite popular, is called React Native. And the idea of React Native is that you can, it was developed by Facebook for cross-platform app development, and it uses JavaScript. So once you write the JavaScript, that JavaScript code is actually converted into native elements. So on iPhone, it'll be Objective-C, and then on Android, it'll turn into Java code. So it'll actually run like a native app. And the nice thing is that the React Native components that you write will have tight platform integrations. And so you can make your app a hybrid. So you can say that I want parts of my app to be platform code. I want it to write an Android component, which is written in pure Android. But for something like the settings screen, or something which doesn't actually require too much on the, it doesn't require too much specifics of the OS. For that, I want to use React Native. And so you have this really nice ability to integrate modules in platform code and modules in React Native. And React Native is pretty tried and tested. So it's already used by Facebook, by Uber, and by Walmart, among many others. And the other major player in my mind is Flutter. So Flutter is created by Google, and they describe it as a UI toolkit for building native apps for mobile, web, and desktop in a single code base. And Flutter, like a common criticism of these cross-platform technologies is that when I turn it into an Android app, it simply doesn't feel that good. Like there was a technology called PhoneGap a while ago, maybe 10 years ago. It was maybe 7 or 8 years ago. It was really popular. And what PhoneGap did is it took a web app and it basically turned your web app into a native mobile app, but it felt very much like a web app. Like it wasn't super responsive. It didn't feel very natural. And so Flutter provides a full native experience by using native compilers. I don't really know exactly how they do it, but basically they take the programming language called Dart. So Dart is the custom language that Google invented for Flutter. They actually invented it to try and replace JavaScript, but didn't work out. And now they're just using it for Flutter. And they're taking Dart and they're using some fancy compilation technology to turn it into a native experience on Android and iOS. So Flutter is a lot newer than React Native. It hasn't been around for that long, but it's growing very rapidly. So I think in the next maybe 2 or 3 or 5 years, it's going to be pretty interesting to watch how does Flutter evolve. And when you are building out your own startup, does it make sense to build out an Android app and then an iOS app separately? Or will you get almost all the same experience delivered to your users by using Flutter, but now you have half the work because now you're only writing the code once? So it's a pretty interesting time to be a mobile developer because you have all these changes. Has anyone used any cross-platform technology like PhoneGap, Flutter, React Native, or anything else? No. Yes. Oni's asking, what would you personally use if you were to build an app tomorrow? This is a really important, like this is a kind of a deep question. And I think, you know what we should do? We should ask the same question to all the panelists next week, because I'm also curious to hear what other people have to say about it. If I were answering the question, I would probably still be building out a native Android app. But I think that's because I've been working with Android for years now, right? So because I already know about Android, I think the cost for me to build up an Android app is actually not that much. And I could do a much better job of doing that compared to trying to learn Flutter at the same level and building a good Flutter app. So I would still build an Android app, and then I'll try and find someone, or I have some basic knowledge of iOS. I'd probably try and build an iOS app. But I think the reason why these are exciting is because for people who don't know much about mobile development, for them, it will be faster to do Flutter or React Native, right? Because at that point, it's much more efficient to just build the app once. If both Kotlin development and Dart development are going to take the same amount of time because you don't know either, then maybe it makes sense to actually go with Dart and build a Flutter app, because then you get the iOS app for free. So I think so that's one aspect, the technology. How familiar are you with the technology? The other aspect is what app are you trying to build? If you're building out like a very basic app, which is like the Yelp clone, right? You don't actually have too much of a need for the deep integration with the platform. So I think in that example, that would be a really good example for where you would want to use Flutter. But if you're doing something like Snapchat or Instagram, which is very tightly integrated with the phone, like you want to use a camera, you might want to pick up audio, you might want to use location data, that kind of thing, it might be easier to stick with the native code, because then you're going to be able to have easier time accessing the APIs from the mobile platform. So I think this is like one of those questions where the answer is depends. There's probably not like a strict answer, but I think in my case, I would probably still stick with the Android app in iOS app individually. Nice. All right, there's one more that I wanted to mention. It's called Xamarin. This is a technology that was bought by Microsoft a couple of years ago, and it uses the Microsoft technology stack, which means that it uses .NET and C#. And similar to Flutter, it also turns into native code. And honestly, I don't really know too much about it. Like, I feel like if you're in the Microsoft ecosystem, Xamarin is somewhat popular, but most people in Silicon Valley, for whatever reason, there's not as much of a stronghold with Microsoft. And so I don't really know too many people who use Xamarin for a production level app, but it might be worth exploring as well if you're going down this route. All right. That's all I had. So right now we're at the end of all the work we're at the end of week 9. All the work for the whole class is done, and you've built out 3 really impressive apps. What I want to kind of leave on is that this is not a stopping point. I would encourage all of you to keep extending these apps and add more functionality, and really build out a portfolio of 3 apps that you're proud of. And I think you already have a lot to be proud of if you've built out these 3. But if you want to go one step further and land that internship or that full-time job with Android, I think that all of you have done a really good start. And I think that if you keep working at this rate, then I'm sure you'll have much more impressive and sophisticated apps than what you already have now. Okay, so with that, we'll wrap up. Next week is a panel discussion. So please attend live if you are able to, and come with questions that you want to ask people who have been working with Android for years now.